Okay, so now we're going to start off with drawing the unit circle. Okay, so first of all, we're going to start off with a nice big circle to have a nice surface area. It doesn't have to be perfect. It can be a little bit crooked, doesn't matter. Dot in the middle, and we're going to draw our 4 quadrants. And quadrants done. And then now you want to do the 30, the 45, and the 60. Okay, that's 30, 45, 60. Okay, first of all, you got to remember what these are, and then the rest you can do the rest of them just by using this quadrant. So this quadrant, I'll see pi over 6, pi over 4, and pi over 3. So that's the first radians for 30, 45, 60, and then you got to remember the cosine and the sine. So the cosine for pi over 4 is square root of 2 over 2. And for this one, it's also square root of 2 over 2 for sine. And for this one, this is square root of 3 over 2. And this one, and the sine for this one is pi 1 over 2. For 60, the cosine is 1 over 2. And the sine is square root of 3 over 2. And now we have the cosines and the sines for 30, 40, 60. This is obviously 0, 1. This is 1, 0. Obviously from that, that's the sine and cosine. But we're good with that. And that's obviously 0, and this is pi over 2.
Okay, so now we're going to find the rest of the unit circle. Let me start by drawing the first 3 lines here. The way I like to remember it is that pi goes into 6. Pi over 6 goes into pi 6 times. So it'll be 1, 2, 3, and then 4, 5, 6. So right here would be 5 pi over 6. Same thing, pi over 4 goes into pi 4 times. So that's pi over 4, 2 pi over 4, 3 pi over 4. And then pi over 3 goes into pi 3 times. So that's pi over 3, and then this is 2 pi over 3. Now for the third quadrant, right here, this is 5 pi over 6, 6 pi over 6, 7 pi over 6, 3 pi over 4, 4 pi over 4, 5 pi over 4, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. Now for the last quadrant, the exact same thing. So 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6. 5 pi over 3, so that'd be 6 pi over 3. 5 pi over 4, 6 pi over 4, 7 pi over 4. And that's how you find the rest of the unit circle just from the first 3.
Now, one of the easiest ways to find out the sine and cosine of each and every one of these is to remember the denominator of each angle. Now, if it's ever going to be over 6, it's always going to look like this. It's always going to be square root of 3 over 2 for cosine, or the x, and it's always going to be 1/2 over sine, or for the y. And if it's over 4, you need to remember that both of them are going to be the same. The cosine and sine, or the x and the y, are both going to be square root of 2 over 2. And then for over 3, it's going to be the opposite of over 6. So basically, it's just going to be 1/2 for the cosine and the x, and the y is going to be square root of 3 over 2. Now, the reason these things don't change is because they're the exact same angles, I suppose, in different quadrants. Now, when they start changing their negative and positive values. Now, when it comes to the angles in other quadrants, that's when they start changing their positives and negatives. For instance, in quadrant 1, now for the first quadrant, all your cosines, sines, and tangents are always going to be positive, hence the ASCT. But for now, for the first quadrant, no matter what happens, you're always going to be positive. Now, let's say we move over here to the second quadrant. since only sine is positive, that means all the y's are going to be positive, but say cosine or tangent on the second quadrant are going to be negative. So it would be something like for pi over 3, for this one, the over 3, it would be negative 1/2, and then square root of 3 over 2. And now we're moving on over here to the third quadrant, where only cosine is positive. Let's use over 4 for an example. So 5 pi over 4, that would mean that square root of 2 over 2 would be positive, but for the sine segment of it, it would be negative. So it would be negative square root of 2 over 2. And then for the last one, where only tangent is positive, whenever you're writing down the coordinates or the sines or cosines for each and every of these angles, you have to remember that they're all going to be negative. So if I write down the over 3 for this, which is going to be square root of 3 over 2 and 1 over 2, it's all going to be negative. So this is going to be negative and this is going to be negative. And if I write down the other coordinates for these, they're also going to be negative. So just remember, if it's ever going to be over 6, it's going to be square root of 3 over 2 and 1/2. If it's ever going to be over 4, you have to put square root of 2 over 2 for both of them. And then if it's ever going to be over 3, you just reverse whatever you had in over 6. And then, depending on what quadrant it is or what angle it is, you're going to have to make sure that you remember to change the positive or negative signs for whether it's for cosine, tangent, or sine. And so, now that we have the rest of the angles and all the correct integer parts of them, this is the entire unit circle, and you have to just remember that for the coordinates, just simply remember the over what number it is for the numerators, remember what quadrants they are in, and then just remember to apply whatever it might be. And there you go. This is the entire unit circle.